Welcome back to Low Stress Math with Mrs. Bono. We are on review 5 from Chapter 5, Linear Functions, getting ready for that test. We're starting with problem number 11, the car repair shop cost. And it says page 6 on the bottom, but I think it's really like page 8 or 9. But it says review 5 on top, so that's good too. All right. A car repair shop charges an hourly rate plus a pickup and delivery fee. The graph below represents the relationship between the total cost of the repair, including the pickup and delivery fee, and the number of hours it takes the shop to complete the repair. Write an equation to represent this linear function. Okay, so highlight the y and find where this is a ray. So where the ray intersects the y is right here at 75. And that's the cost in dollars. So that's 75. If I was going to interpret this graph, that would be the pickup and delivery fee, because I haven't repaired anything yet. I just picked up the car and I'm looking at it and I'm willing to bring it back for $75. But now, how much is it going to cost to repair it? I need to find the rise and the run to find the cost per hour to repair this car. So pick two nice points. I'm going to take this point right here, and it goes from 75, here's another good point, at 225. All right, so from 175 to 225. Each one of the boxes on the vertical rise is 25, so 25, 50. So the rise is 50. And the run, oh, lucky it's only in single hours, so one box, 1 hour, the run is 1 hour. So the cost per hour, $50 for 1 hour. So rise over run, $50 for 1 hour. So M equals 50, B equals 75, Y equals MX plus B, Y equals $50 times the hours plus the $75 pickup and drop-off fee. The two equations below represent different functions. Well, that's nice. Identify each function as linear or nonlinear and state why each function is linear or nonlinear. Well, linear functions have an exponent of 1 and only 1. So looking at function Q, y has an exponent of 1 and x has an exponent of 1. So function Q is linear. The exponent is 1. But now, let's take a closer look at function P. P has 3 over x. Now remember, x is on the bottom. It's 1, but it's -1 because it's on the bottom of the fraction. I could rewrite this as y equals 3x to the -1 plus 2. And that -1 is not 1. Function P is nonlinear. It has a x in the denominator. And that means not linear. All right, number 13. In each table, x represents the input value and y represents the output value. Which table does not represent a function? Now, remember, if it's a function, the x values do not repeat. So looking at just x values, 0, 1, 2, 3, nothing repeats, that's good. X, 3, 2, 1, 0, nothing repeats, that's good. X, 0, 1, 2, 3, nothing repeats, that's good. Oh, look at this one, D. Oh, 3, 3, 3, 3, this is not a function. That's no good. So there's my answer, D, not a function. Which equation describes a linear function? Well, remember, we're back to, does it have an exponent that is not 1? So this one isn't 1, so that's not a function. That's not a linear function. This has x as the exponent. Ugh, that's definitely not a linear function. This has a square, not a linear function. And this one, even though it has a fraction, the x is x to the first power, and the y is y to the first power. There's my linear function. Ba, 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 bam. Okay, which set of ordered pairs could represent a linear function? Again, we are only looking at the x values. -2, 0, 2, 4. Pff, that is a linear function. But this one, now look at this. The ones repeat. And down here, oh, this is a linear function also. Look at that. That's good. It has -2, 0, 2, and 4. That's linear. That's good. And this has 3, 4, 3, 5. Blech. That's not good. The 3's repeat. So no good, no good. A and C both are beautiful. Both have non-repeating x values. Okie dokie doodle. On to number 16. All right, functions w and z are both linear. Thank goodness they told us we don't have to figure it out for ourselves. That's nice. All right, which statement compares the functions is true? So I like it when they're both written as equations because it makes it easier for me. So let's take a look at this one. Here we go. B is the y value when x equals 0. So for function z, I already know b equals 15 and 8/10. Now I have to figure out what the slope is. So is the slope positive or negative? Meh, I don't know yet, but I'll find out. The change in x goes from 0 to 1, so it's adding 1. But the change in y is going down. It's negative. It's going from 15 and 8/10 to 15 and 76/100. Now, I could use a calculator to do this, but I am just going to write it down. It's going from 80 to 76, which is subtracting 4, so it's -400. So what is -400 as a fraction? Let's put that in here. -4 over 100 is -1/25. The calculator will think for me. So m equals -1 over 25. Okay, so let's write that out as a equation. Y equals -1 over 25x plus 15 and 8/10. The slope of the function is equal to, no, that's not true. The slope of the function is less. Ooh, let's see if it's less than. Let's look at these two functions. So here's 0 on a number line. I'm going towards -1. Which would be bigger / which would be smaller? So I'm looking at 1/16 and 1/25. Now, normally 1/25 is smaller than 1/16. But the problem is these are negative numbers. So, which one's going to be closer to 0? I say we change them both back into decimals and compare the decimals because that's usually easier to compare. So, let's take a look at this one. 1 over 16 is 0.625. And 1/25, we already know, my decimal place, decimal 0.4. So they're negative. So this one, 0.04, is closer to 0 than 0.0625. So 1/16, the -1/16 is actually going to be larger than the -1/25. Sorry, it's smaller. So -1/25 is larger. Wow, that was a lot of thinking. Ugh, I don't like that problem. I'm going to give you a problem like that. Okay, the slope of W is less than the slope of Z. Okay, this is W, this is Z, this is true. The y-intercept is equal, no, that's not true. The y-intercept is less, the y-intercept for W is less than the y-intercept for Z. That's not true either. It's bigger. So, B for sure. Which function of x has the least value for the y-intercept? Oh, well, this is 15, this is -3, so far, this one's winning. This is -2, and this is +2, so B has the least value for the y-intercept, smallest number. Last problem, and we are comparing a function as a table and a function that's a graph. So, which function, A or B, has a greater rate of change? Be sure to include the values for the rate of change in your answer. Rate of change, that is the change in y over the change in x. So, 5 to 7, you're adding 2. 1 to 2, you're adding 1. So the change in y over the change in x is 2 over 1, which is just 2. So my rate of change, m, equals 2 for function A. Function B, we're doing rise over run, from 1 to the next. Rise, 1, 2, 3, run 1. Rise 3, run 1. So, rise 3, run 1 versus 2 over 1. Which function has a greater rate of change? Oh, function B. Now I got to write it as a whole sentence because, you know, English kind of matters a little bit. Function B has a greater rate of change. I almost wrote rate of change. That would have looked interesting. Function B has a greater rate of change. 3 is greater than 2. So that's as good as it gets. Okay, take care, and I will talk to you soon. Bye.